Welcome to this video on the topic of indices. In this video, we're going to have a look at how we can manage expressions that contain negative indices. Now, the way in which we do this is we have an index law we can use that tells us that a to the power of negative n can be rewritten as 1 over a to the power of n. So what we've got here is a way of converting between the form containing a negative index and the form that is that has the value represented as a positive index but in the form of a quotient. So effectively all we're doing here is when we see a base raised to a negative power, we change it to a positive, so we go a to the negative n, we change it to a to the n, and then we just stick a 1 over. So this is a simple transformation we can employ. Now let's have a look at actually using it. So in example 1, we've got 2 to the power of negative 1. Applying this transformation, what we can do is we're going to get 2 to the 1, we'll put it downstairs, and then we'll put a 1 upstairs. Now simplifying this, we don't need the exponent of 1 anymore. So 2 to the power of negative 1 is simply the same as writing a half. Now if we test this out in our calculator, we're going to get 2 to the power of negative 1 is the same as 0.5, which is the same as writing a half. So what we've just discovered here is we've got a powerful transformation here which we can use such that when we're working with negative indices, if it's not preferable to use the negative index, we can rewrite it in this form here. Now let's turn our attention to example 2. In example 2 we have x to the power of negative 2. Once again, we're going to use this transformation to rewrite this as a positive index. So we're going to get x to the 2, so we get rid of the negative, and then we stick it over 1. And thus, we've just changed x to the negative 2 into a positive exponent, 1 over x squared. So nice and simple. Example 3, we have 3 multiplied by x to the negative 3. Now this question here, it's a little bit trickier because there's a 3 in front. So what we need to do is we first need to do a little bit of manipulation. What we're going to do is go for an intermediate step and we'll put the 3 out front here, and then we'll put in some implied brackets. Outside or inside the brackets we're going to go x to the negative 3. So what we see is this negative 3 only applies to the x, it doesn't include the 3 here. So when we go ahead and do the transformation, we're going to get 3, and in the brackets, we're going to get 1 over x cubed. Now bringing this all together, the 3 is going to go upstairs, and then the x is going to go downstairs, like so. So what we've got is a way of rewriting this expression here as this expression here. So the negative exponent only applies to the base it is above of. In example 4 we have 2 to the power of negative 3 multiplied by x squared. So using this transformation once again, we're going to get the 2 and we'll go 1 over 2 to the 3. Then this is going to be multiplied by x squared. Now, similar to the previous example, where it's 3 over 1 multiplied, we're going to do the same here. This x squared is going to go above 1. So when we multiply these together, we're going to get x squared over 2 to the 3. And if we wanted to, we could break this down even further and we could go x squared over 8, but because this line over here is a more compact way of using or seeing it, typically we'd leave it as 2 to the power of 3. So you've got a choice, you can either leave it as this line over here, or you can leave it as this. Doesn't really matter too much. But that's what this would evaluate as, getting rid of the negative index. Now example 5. In example 5 we have 1 over x to the negative 2. So what we've got to do here is, once again, we've got to manipulate this ever so slightly. We're going to get 1 over, then inside these brackets here, it's going to turn into 1 over x squared. Now this looks really confusing here, so the form's not ideal to work with. So rather, what we can do, rather than doing this form here, we can get rid of it and we can take a step back. And we can think, what can we do with this negative 1? So we'll go 1 over x to the negative 2. And we'll deal with the 1 over first. So dealing with that, we can actually take negative 1 over at, and it becomes like this. So if we raised inside the brackets here to a negative 1 over, so this line would go back up to this line up here. But that's not intuitive to work with. Rather, what we'll do is we'll use the index law around multiplication of brackets or powers on brackets, and we'll go x negative 2 times negative 1, and it will come out to be x squared. So what you find is that in an example like this, you simply flip the fraction back around. So we want to be avoiding multi-level fractions at all costs because they're just confusing to work with. Alright, example 6 now. We have 3x squared x to the 5 z squared all over 3x squared z to the negative 2. So the only negative index we see in this fraction here is the minus 2. However, the interesting thing is we can do what we did with example 5. So a similar step. What we're going to do is we'll write out the numerator all over again. We'll go 3 squared x to the 5 z squared, and we'll put that all over 1. Then we're going to get each factor individually in the numerator here and write it out like so. So we're going to go 1 over 3 multiplied by 1 over x squared multiplied by 1 over z negative 2. Now, looking at what we have here, it's going to stay the same, so we'll just bring it down once again. But more interesting, we want to have a look at what's going to occur with the rest of the factors here. So I've got times 1 over 3. This 1 over 3, it's going to undergo a similar transformation to what happened in example 5 here. So the 1 over x to the negative 2 just became an x squared. So whatever we had in the numerator down here, we change the index it has on it to a negative or the opposite, and then bring it up into the numerator. So what we can do, rather than having 1 over 3, we can go 3 to the negative 1. And that's going to be over 1. So we simply flip it and multiply it with a negative index. We're going to do the same for the x squared. So we're going to get an x squared, but put a negative in front, and then put it over 1. Adding in the times. And then finally for the z squared here, bring it up, put a negative in front of the 2, so it becomes a double negative, and that becomes over 1. Now cleaning this up, we get the 3 squared x 5 z squared all over 1 times, then the 3 to the negative 1 times x to the negative 2 times z to the positive 2 now, and we can get rid of the fraction altogether. So using this transformation here, we don't have to use quotients anymore. We can simply express everything as a negative index and then use our index law around multiplication. So the 3 squared and the 3 to the negative 1, we simplify that by adding them. The x's, we add the exponents, and the z's, we add those exponents as well. So we're going to get 3, 2 plus negative 1, x, 5 plus negative 2, and then z, 2 plus 2. Simplifying this out, 2 take 1 is 1, so we get 3, x, 5 take 2 is 3, and then for the z, 2 plus 2 is 4. So the simplification of this expression here comes down to this expression down here. So the method that I used in example 6 here is actually my preferred method of dealing with quotients, because you only then have to remember sort of two index laws. You remember that a negative index can simply be flipped or put underneath 1 and vice versa. And by doing this transformation, so from going from this quotient form to this negative index form, you're able to rewrite everything in the numerator as seen in example 6 here when the document decides to load. There we go. So you're able to change all of this quotient here into a single line of mathematics here, which is easier to read. And then it's simply a matter of using the index law of multiplication. So you just add the powers together with the common bases, and thus you come with your final result here. So a much easier way to work. But in summary, this has been a video demonstrating how we deal with negative indices.